So welcome students. So in this question you're given a general second degree equation in x and y, and you're asked to see that if this represents a hyperbola, lambda is equal to which of these numbers. So what is the theory of this question? So if you have a general equation, general second degree equation in x and y, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So this represents a hyperbola if delta not equal to 0 and h square minus ab greater than 0. These are the two conditions which needs to be satisfied if this equation has to be a hyperbola. So now let us first try to apply this condition. H square minus ab has to be greater than 0. So what is h square here? H square is lambda square minus a into b. A is the x coefficient, x square coefficient, b is the y square coefficient. That is 2 plus lambda times lambda minus 1. H square minus ab should be greater than 0. So lambda square minus of 2 lambda plus lambda square minus 2 minus lambda is greater than 0. So lambda square and lambda square gets cancelled. So minus of lambda minus 2 is greater than 0. This means lambda minus 2 is less than 0. That means lambda is less than 2. So for h square minus ab to be greater than 0, lambda has to be less than 2. So whatever number is less than 2, all those numbers are valid. So lambda is equal to 4 is not valid, obviously. So lambda is equal to 4 by 3 is valid. This is valid, this is valid. These three are valid. Now the next condition is the delta should not be equal to 0. That means the determinant of A, H, G, H, B, F, G, F, C. This should not be equal to 0. So let us apply this condition. So according to this condition, if you apply this for this problem, so 2 plus lambda, H is minus lambda, G is minus 2. So minus lambda, B is lambda minus 1 and F is 0. And finally minus 2, 0, minus 2 should not be equal to 0. So if you expand this determinant, so I will take a minus 2 common from this row. If I take a minus 2 as common, that also should not be equal to 0. So this row becomes 1, 0, 1. Now I'll expand this with respect to the last row. So what do you get? 1 times minus lambda into 0 is 0. So 2 times lambda minus 1 plus 1 times again. So 2 plus lambda into lambda minus 1 minus lambda square should not be equal to 0. So 2 lambda minus 2 plus, so if you expand this, you get 2 lambda plus lambda square minus 2 minus lambda square should not be equal to 0. So lambda square and lambda square gets cancelled. So 2 lambda plus 2 lambda, 4 lambda minus lambda. It is 3 lambda minus 4 should not be equal to 0. So lambda should not be equal to 4 by 3. So as long as lambda is not equal to 4 by 3, delta will not be equal to 0. That means exactly when lambda is equal to 4 by 3, this represents a pair of lengths. So as long as lambda is not equal to 4 by 3 and obviously less than 2, so this equation will represent a hyperbola. So what are the possible options? So this is not a valid option because when lambda is equal to 4 by 3, delta will be equal to 0 and this represents a pair of lengths. So lambda equal to 1 is okay, lambda is equal to minus 1 is also okay. Thank you.